we left off, I think, where did I saw it? On page 204, we gotten through 20, right? Now, no class this Friday. Then Monday, not next week, but the next week, right? We get the Monday after Easter is off.
Yes.
So there's no class. And then I think then finals, the last day we'll actually, have class is right at the end of April, isn't it? Because the finals start
First week in May.
yeah, and it runs a week long. So the end of the month.
Is there a possibility we could move the finals to the week before finals week?
Well, I'll what do you got? What do you got? Okay, so page 204. And they're saying refer to those diagrams. And probably better draw them. This angle. All right. So what you have, what you can actually say is that the triangle A, B, A, I wrote D, A, B, C is congruent to triangle D, E, F, and that's angle side angle, right? And because of that, then therefore you can say that angle A is congruent to angle D. And I guess that's given, right? That'd just be given. Then it says FED. Well, we've actually answered it because that ABC and DEF is the same thing as triangle FED congruent to the triangle. And then to get to coordinate, F would be C. Then E would be B, A. And that's angle side angle.
Would that be given to?
How's that?
Would that be given to? Side angles.
Did you get it answered?
Yeah.
Okay. Then, see, this was 24. This was 22. And then 26. And that's angle F. Well, angle F has to equal angle C, right? And that's probably being we're using congruency. its corresponding parts of congruent triangles. All right. In the next group, they're telling you that's a regular hexagon. So 28. See if I can show it from there. That isn't quite regular hexagon. What the heck? A, B, C, D, E, and F. C here. C. Okay. We'll just go through all those. 27. Angle B is congruent to. And that would be, you could do angle B congruent to angle D. It's actually congruent to C, D, E, F, and A because it's a regular hexagon, right? And 28, what you can do is if angle B and D are congruent, then the side AB is congruent to ED, and the side BC, I guess BC is congruent to side DE, DC. And that's regular hexagon 2 definition. So, then on 28 you can say the triangle BAC is congruent to BAC. C triangle CDE, and that would be what? Side angle side. This would be congruent to this one, to this one, and then this angle to that angle. So it's side angle side, they're congruent. Then they're saying AC of 29, AC is congruent to, then what you do is you do EC, and that's corresponding parts of congruent triangles. And 30, let's say angle BAC congruent to, so BAC is going to be congruent to what? BAC. DEC. And that's corresponding parts. And then 31 would be angle FEC. So FEC. And you do FAC. Congruent to and what that is, what you have is you have this angle right here and this angle are equal because of the regular hexagon. And then we've just shown by corresponding parts that this angle and this angle are equal. Therefore, you can say that this angle and this angle are equal. Now, I guess it would be several steps that you could do. I'm just going to leave that for you, because there'd be several steps that it involve in try to show it. Okay, what was this? 31, 32. Then triangle FEC. 32. Triangle FEC. FEC. So if you did you'd have to do this. You'd have to say that AF, this side and this side are congruent. AF congruent to EF. And that's a definition of regular hexagon. Now then, what we've shown is that this side and this side are congruent. That was previously shown. So then you could say that FEC is congruent to triangle FAC, and that would be for what reason? Side angle side, right? Correct? Okay. Now you could actually do it another way. You could say this side right here is congruent to itself, and then you could say the two are congruent by side, right? But the direction that they're taking you is that they want to go side angle side. I mean, that purple one, it'd be reflexive property. Say that those are equal. Okay. says in the figure shown. Give that a shot.
Professor, quick question, what was the reason for 26? Because it was congruent
26.
to ASA?
Corresponding parts of congruent triangles.
Okay. Thanks.
Mhm. Let's see. I did this thing.
Alternate angle.
Yeah.
And as hard as I tried, I still can't think. So A, B, C, and D. So they're saying in the figure, angle BAC, and this is, they're talking about proof, so they want to, have us write a little bit better proofs than what I've been doing, I guess. BAC is congruent to DAC. So BAC is congruent to DAC. So it's these two. Okay. I can't silence that thing. Okay. And then ACB, ACD. This is ACB and ACD. Prove that AB is congruent to AD. And so they're just saying, show first of all that the two triangles are congruent. So on 34, what we'd want to do is we want to say that angle BAC is congruent to angle DAC, and then we give the reason given.
ASA.
Well, yeah, but the only thing is we have to write the proof out. That's because they say proof, so you want to write the proof out. So then you'd say angle ACB is congruent to angle ACD. Then you'd say that's given. Then you would do what you're saying is that you would say that AC is congruent to AC, and the reason would be what? Reflexive? Property. Then you'd say triangle. I guess they're saying ABC is the way they want you to write it. Triangle ABC congruent to A triangle ABC, and that would be angle side angle, right?
Mm-hmm.
And then what they want you to show is AB, you'd say therefore AB is congruent to AD, and this would be corresponding parts of congruent triangles. So when you write that, you know, if you're asked to do a proof, that's what you want to do it step by step.
You say AC is congruent to AC?
Yeah, that's reflexive. It reflects back on itself.
Okay.
Yeah. That way you can get that angle side angle for those two triangles. Okay.
Oh, hold on.
Oh. Okay. It's P, Q, R, S, T. So this is, I mean, you can see it obviously, but then what you want to do is write the proof. So we're going to show, because angle Q and angle T is what we want to prove congruent, but we got to prove the two triangles congruent. They've given you everything necessary, right? So you,
Is this on the not alternate angles?
what's that?
Is it Q and T not alternate angles?
Yeah, Q and T, you know, are corresponding parts of congruent triangles. But you got to do all the steps. That's the thing. You got to do the proof steps. That's so what you do is you'd say P Q is congruent to, and what you want to do is you'd want to do S T, and that's a given. And you want to, you know, make sure that I'm doing it right, that I'm writing it the direction right. I mean, that's, you've got to do the direction right and do the right one. So then then you'd say P R is congruent to S R, and that's given. Then you could go Q R is congruent to T R, and that's given. Then you'd say triangle, and it doesn't make any difference, but you got to write it this right. So if I went R Q P is congruent to triangle, then I would want to go R T S, and that would be side, side, side. Then you'd say therefore angle Q is congruent to angle T, and that would be corresponding parts of congruent triangles. It's not that it's obviously true, it's writing the steps to show that it's true. That's what this exercise, you can see it's obviously true. But you want to write, and then you want to write when you do the sides, write the sides so that you know, the direction is right for, I mean, I don't care whether you do PQ is congruent to ST, or if you do QP is congruent to TS, just make sure that, you know, the direction is right, correct for the triangle. Understand what I'm saying? That's, you know, it's real obvious. You could say, well, sure, you know, they're congruent triangles, and therefore angle Q is congruent to angle T. But they want you to write step by step in an active form. And that's what it's about.